Okay, so thanks for the nice introduction from Dr. Kitchener, and it is my pleasure to being here today to introducing you about our new efficient phenotyping platform in grape wine researchers, the Phenoliner 2.0. First of all, I will give you a general introduction about viticultures in Germany. So maybe you know grape wine is one of the most economical important fruit crop worldwide. And in Germany, 99% of the grape productions was used for wine producing. And so far, Germany is the fourth in Europe and ninth worldwide wine producers. And the annual consumption in Germany is also very high, so more than 20 liters per person. So far, there are 13 wine-growing regions in Germany as a certificate, and they are mainly located in the southwest of Germany, and some of with more than 100,000 hectares vineyard, with most productions in 2019 of 8 million hectoliters and wine productions of 70.6 million hectoliters. Rheinhessen, Pfalz, Baden-Württemberg, and Mosel is the 5 leading wine-growing regions in Germany, except for Württemberg. The rest of 4 regions is preferred to produce more white wine than red wine. Based on different criteria such as growing regions, sugar contents, permissions of sugar enrichments, minimums of alcohols, the wine in Germany are classified into 4 different classes. The lowest one, the Deutsche Wein, they have the lowest requirements of mass weight, around 44 degrees Celsius to 55 degrees Celsius, and the highest classes wine, the Predica wine, which is no additional sugars enrichment was allowed in these classes. They have a relative higher sugar content, varianted from 76 degrees Celsius to more than 150 degrees Celsius, like in the Trockenbeeren Auslese. In the last 20 years, the productions of quality and above wine in Germany is quite high, so they are always more than 94%. However, if you see in detail to see the percentage of Predica wine, which is the better wine, they are evaluated with years. The highest one, they can achieve a 55% of productions, and in the back years is only 70%. Except for genetic backgrounds, the influence from the environmental factors play also an important role, such as temperature, precipitations, radiations, abiotic and biotic stress. Here I will more focus on the biotic stress. So here I will give you examples which was published by Summer in 2008 about the Paldimedium infections on Chardonnay in 2001. First, we see the chemical compositions of the grapes. We can see here the juices which was higher from the grapes with higher infections. They have a lower sugar content compared to the healthy plant. And meanwhile, the acetic acid levels and phenol level is also increased after infections. Except for the juices quality, the taste of the wine is also strongly affected by the infections of fungus. And as the results show that the wine produced by the grape, which is the grape which is infected strongly by Paldimedium, they are tasting more estery and more oily, which is not desirable for the wine producers and also the wine consumers. The overaim in the grape wine breeding is to breed a candidate variety which has optimal years, a high quality, and ability to resist against biotic and abiotic stress. To achieve this goal, we always phenotyping during the selection process is quite important. We are observing different factors such as vitality, the growth rate, leaf area, can mass, and resistant ability of the candidate, the quantity of the products, how much weight, number, and size of the berry and branches, and also the quality of the products, such as the sugar and acid content in the mass, and the alcohol, phenol, aroma, and acids in the wine. Besides, we also focus on the viticultural relevance characteristics such as the growth, architectures, a plant with a good with optimal grow architectures could be easier for the grape grower to manage their farm during the growing seasons. However, grape vine is a perennial wooding plant. That means most of the selective process in the breeding are taken place in the field test and very, very time consuming. The optimal time windows for biotic stress, biotic fungi to infect the plant is only about 2 months from June to August. Therefore, they provide us, the breeder, a quite narrow time window to screening so many material in the same times, which limits our capability to do selections for more candidates. Besides, so far, the assessments of such parameters or such phenological parameters are based on human observations, which is not objective enough. In order to achieve higher or objective phenotyping of our candidates variety, a Phenoliner 1.0 was conducted by Dr. Kirchner and published in 2017. This platform was based on a modified aero harvesters. These harvesters will remove all the harvest units such as shaking units, desteamers, grape tanks, and transport banks. Instead of that, a sensor system consisted of a hyperspectral camera, 4 RGB camera, and 1 near-infrared camera located in the tunnels of the machine. In order to have a standardized light, a LED light bank was circles in around of the sensor systems. This platform provides us a quite robust systems for a sensor-based phenotyping in the field, and the image acquired from this system can also GSP reference. Because we use artificial light in the tunnels of the machine, therefore this machine can screening our material for in any time of the day, independent of the surrounding light conditions. However, we still face a couple of problems. So far, this machine can only working in a quite low spinning speed, maximum at 1 kilometers per hour, because we use different cameras in different positions. Therefore, we also have problems of deviations of image positions. In order to overcome such shortage, we have upgraded our Phenoliner 1.0 to 2.0 now. Instead of the sensors I mentioned before, we use a new sensor system from Fusion series FS3200T from JAI, which is a dichroic prime space 3 CMOS multiple spectral area scan camera, consisted of a visual and 2 separated near-infrared bands. The explosions of each channels can be separated control. Besides that, we also conducted a computer systems consisted of a wireline assessment point and an external storage plate. As in the Phenoliner 1, the sensor camera was located in the tunnels. However, the computer unit is quite flexible, and we are located it on the top of the machines. In order to control our systems and adjust the parameter in real time, a user interface was programmed by Fraunhofer as well to connect it by internet to control our systems. So far, with the new updated systems, we have flexible positions of the camera and local host, and with the use of new sensor systems with simultaneous 3 channels provides us a perfect channel alignment and a multiplied detections of single setup, and it's quite easy to use. And compared to several cameras, one camera provides us a lower cost. So far, we also test our phenotyping platform in the experimental vineyard in Geilweilerhof Julius Kühe Institute, we can taking 10 pictures per second at a driving speed at 4 to 6 kilometers per hour. Here I also show you examples here. In the left-hand side is the RGB image, and in the right-hand side is the normalized different vegetation index, which is calculated based on the near-infrared informations. And this index is normally used for remote sensing detections to give you the vitality situation of the green plant. To further applications of these phenotyping systems, we consider two scenarios in the future. One is for selective harvesting, which is more focused to do harvests excluding the disease grape in order to increase the overall wine or grape mass quality to the end. And for this aims, we only need the system to have a yes and no decisions to identify whether there is plant there, whether there's fruit visible, and whether these fruits are healthy, and maybe even establish the years for harvesting. Once the system received the answer of no, the harvester will stop their shaker, and such grape with bad quality were not included in the tank. And for the second scenario, the phenotyping, we prefer to more well documented our mass of sensing data, and we hope that the new system can automatically identify the grape wine with parameter of interest. To this aim, we need the system to identify which disease can be found in this unhealthy fruit. And all this disease informations and the lack of the year information were stored in the database, and based on this database, we can also produce an information map in the future and use for further applications. As a sum up and outlook for my presentation today, we can now proud to say that our PhenoLiner 2.0 enable a high throughput image acquisitions in WinYA up to 6 kilometers per hour, which was 1 kilometer per hour before, and enable to record more information in a high resolutions with multi-channels camera systems, and with the locations of the flexible locations of our computer system, it make it capable to achieve a real-time analysis of image during the acquisitions. To further develop our systems, we will use the image that we acquired last years for our algorithmus training. Let the system to automatically segment the image into stem, shoot, leaf, and grape branches. And also we want it to distinguish between healthy and diseased plants. Last but not least, I want to thank you, Dr. Kicherer and Professor Töpfer, for letting me to enjoy this project DigiWine, financially supported by Bundesministerium für Ernährung und Landwirtschaft, and also our colleague Lucy and Katrin Maximilians for their support in the work, and a very grateful thanks from our cooperator partner from Frau Höfer und Aero for their technical support. In our project, we have more digital solutions in different applications, cases in viticultures. If you have more interesting to know more, you can visit our homepage, thedigiwine.org. If you want to follow our latest information, you can also follow us via Instagram, Twitter, or YouTube channel. And thank you for your attention, and welcome for the questions.